Hi, it's me again, and we're going to talk this week in another series of short videos on how refracs can help make America's old oil and gas wells great again. Last week we talked about getting the right team in place, making sure you got the right players on board, that all your disciplines are covered. This week we're going to talk about, determining the size of the prize, just what's there. Is there something worth refracking in that rock? The process, the concept is fairly simple. You determine what was there originally, and then you determine what's come out, and therefore that's what's left. The details is where the devil is always in the details. Getting a good petrophysical model is not always straightforward. There's a lot of discussion on the best way to analyze your oil in place, and particularly in resource plays. You see a lot of claims that you can identify 8 or 10 minerals in the rock and try to back out the properties from there, and it's possible, but typically one curve gives you one output reliably, and typically you only have a triple combo. So it's kind of hard to do that. And kerogen too is another issue. How do you take kerogen out? We like to do it with an empirical model tied to core, whereas if you try to actually measure the volume of kerogen, what is kerogen? How much TLC is kerogen in liquids rich rock? Gas is fairly straightforward. But in liquids, it's S1 and S2, so it's the mobile and the immobile hydrocarbons. How do you know that? So you're making a lot of assumptions sometimes. The key is to tie back to core, and then also normalization is critical. We've seen so many instances where normalization made huge differences in what your resource is, and because you're dealing with vintage logs, you're going back into old areas that have been, most of your well control is vintage logs. Legacy logs. So, a lot of times you've got varying log qualities, so you have to normalize, and we spend a lot of time doing that. And putting it all together, making sure that your porosity maps well. You want to integrate it with the geology. You're measuring a very small part of the rock, and typically you're going to have wells maybe a mile or two apart, but you're trying to map over an area. So, the geology input's important, and map your porosity, map your water saturation, map your thickness. And that also tells you sometimes if you got issues with your data, if you've got outliers. Maybe they're running the wrong resistivity tool, for instance. That'll tell you right away if your saturation's a bust, for no geological reason. But, tie it all together, and then look at your recoveries. See what kind of EURs are you getting out of the rock. There should be a fairly consistent recovery factor as a function of your completion. And knowing what's producing vertically is important. That's where rock mechanics come in, brittleness. Some areas, for instance, only produce from the propped height in low modulus rock, or less brittle rock, or ductile rock. And other places you have a significant amount. Most of your height is unpropped. You got to know that ahead of time. So tying all that together, making sure it fits, and that's really the main thing about petrophysical characterization. Try to make sure you got good numbers going in, because it's a huge GIGO exercise if you don't. You got to make sure you do everything right. We like to think we've got a pretty good program for doing that. And the proof is in the pudding. If you can predict EURs from wells within a reasonable range, that's pretty good. That's typically your target, to go into an area and try to predict what's going to come out of the ground. And that gives you your target for your refrac. If you go back and your recovery factor is 2% on the original well, and it's 12%, or we're seeing in the Wolfcamp now 14%, that delta is your refrac target, minus your EUR, minus your cum, But at any rate, you can fairly straightforward put together a model that's going to make it work. But at any rate, that's all we got for this week. Next week we'll talk about the mechanical reasons why the oil and gas is still there, so you don't repeat the same mistakes. And then the last week we'll talk about the best practices for getting the oil and gas out once you've got all the other information that you work with. Thanks for your time. We'll talk to you next week.